Alright, video 3. What volume is occupied by 0.58 moles of a gas at 98.4 kilopascals and 11 degrees Celsius? So it's asking for volume of a gas, and because it says gas, I know to look at my behavior of gases formula. My behavior of gases formula, I have an equation that has pressure, volume, moles, constant, and temperature. So I have moles, I have pressure, I have temperature, and it's asking for volume, and my R is always given, so I'm going to use this equation. So it's PV equals nRT. So I need to remember that PV equals nRT does not use Celsius, it actually uses Kelvin, so I need to put 11 degrees Celsius plus 273, that's my conversion. And I did not memorize this, I actually just look here, and it tells me that 0 degrees Celsius is the same thing as 273 Kelvin, so I just have to add 273 to go from Celsius to Kelvin, so I have 284 Kelvin. And I'm looking for volume, so I need to get the V alone. So I'm going to have volume is equal to nRT over P. Alright, so now I just have to plug it in. So I know that my moles is 0.58. I know that my temperature is 284 Kelvin. I know that my pressure is 98.4 kilopascals. What I don't remember is my ideal gas constant, but my green sheet gives it to me. So I have 3 ideal gas constants, and I'm going to use the one that matches the units I'm given. So I'm not given atmospheres and I'm not given millimeters of mercury. What I'm given is kilopascal, so I'm going to use this. So I have 8.31 liters kilopascals over mole Kelvin. So I'm going to put this in my calculator. I'm using my 89 right now, so 0.58 times 8.31 times 284 equal, I'm going to divide that by 98.4. So my volume is 13.9 liters. Alright, the next question, video 3, is what is the molar mass of a gas at 142 grams of the gas if the gas occupies a volume of 45.1 liters at 28.4 degrees Celsius and 94.6 kilopascals. So I'm looking for the molar mass of something. So when I look for the molar mass, I'm still going to use the same equation, PV equals nRT. So I'm going to find moles alone. So I just need to plug things in. Remembering to change my 28.4 into Kelvin. So I have 28.4 plus 273. And I don't trust myself today. 28.4. So that's 301.4. Okay. So now all I have to do is plug it in. So I already have my pressure. So my pressure is 94.6. My volume is 45.1. My constant, I'm kilopascal, so it's still my 8.31. And my temperature is 301.4. So Now I just plug that in. So I'm going to do 94.6 times 45.1. I'm going to divide that by 8.31 times 301.4. It's going to equal 1.70. So that is how many moles I have. But I'm not looking for moles. I'm actually looking for molar mass. So I'm going to divide the 142 by 1.70. So 142 divided by my answer. So I have 83.36, or roughly about 83.4 grams per mole. And lastly, a certain mass of a gas at 2.25 liters. Liter container has a pressure of 164 kilopascals, whereas the new pressure of the volume of the container is reduced to 1.5. So I have a container and I am going to pressurize it. I'm going to reduce how much space it has available. So I'm going to use my P1 V1 equals P2 V2. So I'm going to plug that in. My initial pressure is 164. I'll multiply that by 2.25. That's going to equal pressure 2. And my volume is 1.50 liters. I'm going to divide by 1.50 on both sides. So I'm going to do 164 times 2.25 divided by 1.5. That equals 246 kilopascals. And that makes sense because if I have less space but the same amount of material, the pressure will increase.